In this section, we are discussing principles of mathematical induction. You know how to solve a basic problem, and mainly we are discussing today, in this section we are discussing how we can solve an inequality-based principles of mathematical induction question. Before starting this one, you should know some basic ideas. You know, the principles of mathematical induction mainly we are using for what? Natural numbers. Only natural numbers only. P of n is true for all positive numbers or natural numbers. So I want to tell some basic concept. Listen. You know, 3 greater than what? 2. It is a natural number, 3 greater than 2. You can add any natural number on bigger side, inequality, nothing will happen. Any natural number you can add on bigger side, inequality, nothing will happen. For example, this is the bigger side. If I am adding 1, inequality still remain, still it is only greater. So if I am adding along with that one 10, nothing will happen. So if you are adding any natural number on bigger side, this inequality, nothing will happen. It is still what? It is greater only. But in the case of equation, it is not possible. For example, 3 equal to what? 2 plus 1. If you are adding something over here, the inequality will what? So the equality will become what? Greater. So don't forget this concept. If you are adding any natural number on bigger side, inequality will remain same. Still it will be what? Greater only. You know, the mouth where it is open, that part will be greater. So same way, if you are subtracting any natural number from the smaller side, also nothing will happen. You can see that one. For example, 10 greater than 5. You subtract just 1. Still what? That is smaller only. This one is what? Greater only. Or you can subtract what? 4. What about? If you are subtracting any number, you can any natural number you can subtract 5 minus 7. Still this part will be greater. So don't forget, when we are solving an inequality based question, don't forget, bigger side we can add anything what we need, and smaller side we can subtract anything. From the smaller side we can subtract anything. That concept don't forget. Bigger side we can add, smaller side we can subtract. So if this concept, if it is clear, mainly only for natural number, if this concept is clear, easily we can simplify an inequality based questions. Okay, first question, please note it down. Please write. Prove that, this is the question. Prove that 1 plus 2 plus 3 plus etc. plus n less than 2n plus 1 whole square divided by 8 for all n belongs to n. For all n belongs to n. We want to prove this one by using what? Principles of mathematical induction. How we can solve it? Very simple only. What is the first procedure? First we have to call a name P of n. Let P of n this one. And what is the first procedure for n equal to 1? That you know, for n equal to 1, what will be? P of 1, left side only 1 will be there. Right side is what? It is an inequality. 2 into 1 plus 1 whole square by 8. Is it? Wherever n is there, I replace it by what? 1. So this will be P of 1, 1 less than 2 into 1. This is how much? 1 less than, this is 3, 9 by 8. 9 by 8 means 1 point something, that is greater than. So what we can say, P of 1 is true. P of 1 is what? True. I hope P of 1 is true. You understood this one. I hope this part you understood. Next, what is the next procedure? Assumption. We have to assume P of k is true for some positive integer k. We have to assume. So assumption is next part. So I hope you wrote this one. So P of assumption. Assume that P of k is true for some positive integer k. That is P of k 1 plus 2 plus 3 plus etc. plus k less than what? 2k plus 1 whole square by 8. This we are calling equation number 1. Now we have to prove that P of k plus 1 is also true. We have to prove that P of k plus 1. That is to prove P of k plus 1. How we are writing? P of k plus 1, 1 plus 2 plus etc. plus k plus 1. Less than, you know that one. K means up to k plus 1 means up to k plus 1. So we have to write the previous term also. That we already done in the basic questions. So what will be the right side? 2 into k plus 1 whole square by 8. That is what we want to prove. 2k plus 3 whole square by 8. Because 2 into k, 2k, 2 into 1, 2, 2 plus 1. We want to prove 2k, this less than 2k plus 3 whole square by 8 we want to prove. Now how we are doing? This is an inequality based question. So first the LHS part we will write. Listen, sorry, not LHS part. This proof we are doing to get it easily. This proof directly from equation. Usually in previous part what we did, this one LHS will write and will do by using that from 1. But here it is not like that. To get it easily, the procedure what we are doing, from 1 directly we are writing. Listen, proof. This we want to prove. From 1, we have this directly you write 1 plus 2 plus 3 plus etc. plus k less than 2k plus 1 whole square by 8. This is our assumption only. That only we are using. 2k plus 1 whole square by 8. But we want to get this less than this one. So what we want to get left side? Left side already we have k. So what we want to add to get left side? So addition or multiplication or subtraction, whatever thing we need at that time, that we have to check. In this case already it is there up to k. We want to get what? K plus 1 also. So next line, adding both sides k plus 1. Here what I told you in the beginning that I am not using, that when it is needed at that time only we'll check it. So adding both sides k plus 1. Why we are adding k plus 1? Because left side I want to get k plus 1. Right side you don't care, that automatically will come. So both sides, adding both sides what? K plus 1. Adding both sides, I hope you write it. Adding both sides is what? K plus 1. What will be? 1 plus 2 plus 3 plus etc. K plus 1. The same thing we have to add right side also. 2k plus 1 whole square by 8 k plus 1. So our left side is okay with us. Now right side what we want to get? We want to get 2k plus 3 whole square by 8. How will we get it? That is the next attempt I am going to do. Listen, here one line I am drawing. This line nothing, only this one I am simplifying separately. Actually the same symbol we have to put it down. Because left side the same thing only. This I am separately simplifying. How we can simplify? You can see 4k square plus 4k plus 1 plus LCM. This I open. After that 8 when we are transposing, 8k plus 8 all divided by 8. So what you will get? 4k square plus 12k plus 9 all divided by 8. What is 4k square plus 12? That is actually this one. In working column you can write it. What is 2k plus 3 whole square? It will be 4k square plus 12k plus 9. So what we can write after this step? Sorry, I am writing here. After this step, what we can write? Left side is same thing only. 1 plus 2 plus etc. k plus 1 less than. What is this actually? It is the expansion of 2k plus 3 whole square. So what we can write that? 2k plus 3 whole square by 8. Directly we wrote. What I told you in the beginning, adding and subtracting, that I didn't use so far. If it is needed at that time, we'll see. I hope you understood this part. I hope this is clear. Now the conclusion will be that, what is that? Thus, P of k plus 1 is true whenever P of k is true. Why? Because we used what? P of k result. Because that's our assumption. Therefore, by PMI, P of n is true for all natural number n. This already you know. So this proof is over. Now, next question. 3 more questions we'll do. Next question we are discussing after this. Okay. We can continue. Next question. Prove by using induction. Prove that this one. 1 plus x all raised to n greater than or equal to 1 plus nx. Condition is that. The condition is that x greater than minus 1. x greater than minus 1. X greater than minus 1. That is a condition. That you don't care, we have to do this one. So again it is an inequality. Here what I told you in the beginning, adding and subtracting we need. So first what is the procedure? We have to give a name. Let P of n, I given a name. Then what? For n equal to 1, this step is common thing only. For n equal to 1, P of 1 will be what? 1 plus x all raised to 1 greater than or equal to 1 plus 1 into x. So 1 plus x what? Greater than or equal to 1 plus x. Already equal sign is there. Either 1 plus x can be equal to 1 plus x or greater. Anyway already it became what? Equal. So what we can say? P of 1 is true. P of 1 is true. I hope you understood. First part is over. Next what? Second part. Second part is what? Assumption. Assume that P of k is true for some positive integer k. This is our assumption, don't forget. This is what? 1 plus x all raised to k greater than or equal to 1 plus kx, equation number 1. You know, wherever n is there, I replace it by what? K. We discussed it many times. So we have to prove that P of k plus 1 also true. Now we have to prove that P of k plus 1 is also true. That is what? To prove P of k plus 1 will be what? 1 plus x whole raised to k plus 1 greater than or equal to 1 plus k plus 1 into x. So this we want to prove. I told you inequality directly from equation number 1 we are starting. And don't forget about in the inequality, I told you already, in bigger side we can add anything. In the case of inequality, bigger side we can add anything and smaller side we can remove anything. I mean subtract anything. From the smaller side you can remove anything, you can remove without anything you can remove it. From the smaller side you can remove anything, but bigger side you can add anything. Don't forget about that. But it is only applicable for natural numbers. So that concept I need in this question. Previous question directly we got the result, that's why I didn't do anything. Now this case, okay, proof. How we are proving it? I told you inequality usually we are taking from where? Equation number 1. From 1 we have what we have? 1 plus x whole raised to k greater than or equal to 1 plus kx. This we have. I told you after that what do you want to get in LHS? What do you want to get in the LHS? That please check it. You want to get in LHS what? 1 plus x whole raised to right side, you don't need to check that, automatically will come. In left side you want to get 1 plus x whole raised to k plus 1. Here we have only 1 plus x whole raised to k. Previous question we added on both sides. Here not addition. Here it is what? Multiplication. Why we are multiplying? Because 1 plus x whole raised to k plus 1 meaning 1 plus x whole raised to k into 1 plus x. You know, a raised to m plus n result. A raised to m into a raised to n. So this case multiplying both sides what? 1 plus x. Multiplying both sides 1 plus x. What will be? 1 plus x all raised to k plus 3 into 1 plus x greater than or equal to 1 plus kx into what? 1 plus x. Both sides I multiplied 1 plus x. Now what? This you know, a raised to m into a raised to n is what? A raised to m plus n. So our left side is ready with us. Greater than or equal to, this you have to open. This when we are opening, you will get 1 plus kx plus 1 into 1 kx into, after that 1 into x, after that kx square. So I told you, you can draw a line. We can simplify it. So I'm going to simplify this part. 1 plus, this is what is common, x is common, I'm going to take it out, plus kx square, plus kx square. See, this much I got. Now, this inequality if you are putting down, nothing will happen. See, actually we want to get, here left side what we have, 1 plus x whole raised to what? K plus 1. Actually what we want to get 1 plus k plus 1 into x. But here we have 1 plus k plus 1 into x plus kx square. I told you in the beginning, from the smaller part you can remove anything. From the smaller part you can remove anything, But if it is bigger part, you can add anything. Bigger part you cannot subtract, you cannot remove. Bigger part addition only possible, but smaller part you can remove anything. So without any problem, you people can remove which one? Kx square you can remove. That is inequality. Natural number only it will be. If in the case of inequality you can do that one. So when we are removing, what will be? That is what we can write 1 plus x whole raised to k plus 1 greater than or equal to 1 plus k plus 1 into x. Why we removed? What we want to get, that you have to check. So accordingly I rearrange it. But previous question, you might remember that one. In that case, directly we reached the result. That's why I didn't do anything. This we are doing at the end only. That will you want to prove. So what will be the condition? Thus P of k plus 1 is true whenever P of k is true. Therefore by PMI, P of n is true for all natural number n. That already we wrote each and every question, so you can write it. Now next question is coming. Hi, we are continuing this one. Next question is 2n plus 7 less than n plus 3 whole square, that we want to prove. Again inequality, this is bigger side, this is what? Smaller side. Where that mouth is open part, that will be what? Greater. Yet this is greater and this is smaller. We want to prove this one. Again the same procedure. First we have to give a name. Let P of n, this one. What is the first thing? For n equal to 1. For n equal to 1, this everything you can write, I think. 2 into 1 plus 7 less than 1 plus 3 whole square. 2 into 1, 2 plus 7, 9 less than 16. P of 1 is what? True. 2 into 1, you know this board mass. After the multiplication only you have to do what? Addition. So what we got? This is 9. 9 less than 16. Correct only. 16 is bigger than 9. So P of 1 is true. What is the next assumption? Assume that P of k is true for some positive integer k. Assume that P of k is true for some positive integer k. That is P of k 2k plus 7 k plus 3 whole square. Equation number 1. What is next? Now we have to prove that P of k plus 1 is also true. Now we have to prove that P of k plus 1 is also true. That is to prove P of k plus 1 2 into k plus 1 plus 7 less than, wherever k is there we have to replace by what? K plus 1. Or what we want to prove? 2k plus 2k plus 9 less than k plus 4 whole square. This we want to prove. Because 2 into k, 2k plus 2 and 9. This we want to prove. How we are proving inequality? Directly from equation 1 we are starting it. So proof. From 1 we have what? 2k plus 7 less than k plus 3 whole square. Is it? 2k plus 7. Actually what we need is 2k plus 9 we need. So adding both sides of which 2. Because to get, previous question was multiplication. This case we want to get 9. So 2 needed. So adding both sides by what? 2. So adding 2 on both sides, what will you get? 2k plus 7 plus 2 less than k plus 3 whole square plus 2. So this is what? 2k plus 9 less than k square plus 6k plus 9 plus 2. Balance I am writing here. So you can see 2k plus 9 less than k square plus 6k plus 11. So listen, I told you in the beginning, again I repeat, smaller side you can remove anything, bigger side you can add anything. See in this case, smaller side already ready with us because that only we want to prove. This only we want to prove. Don't forget, this only we want to prove. That is okay with us. Only the right side is the problem. Right side actually what we want to get, that you have to check in between. We want to get this one. What is that actually? K square plus, yes, 8k plus 16. Actually we want to get k square plus 8k plus 16, that we want to get. But here we have only what? K square plus 6k plus 11. K square plus 6k plus 11 only we have. We want to get what? This one. So 8k, here 6k. Here 16, here 11. So bigger side we can add. I already told you. So this side I'm going to add nothing will happen inequality 2k plus 5. Why I added 2k plus 5? Because I want to get this bigger side we can add anything, smaller side we can remove anything. So that is a bigger side. So what we got this one, 2k plus 9 less than k square plus 8k plus 16. That is 2k plus 9 less than k plus 4 whole square. That is proved. So what is the conclusion? Thus P of k plus 1 is true whenever P of k is true. I hope you understood it. So bigger side we can add anything, smaller side we can remove anything. That concept only I used. Okay, I hope you understood it. Now next one. Okay, next one say, again PMI only. Prove that 1 square plus 2 square plus 3 square plus etc plus n square greater than n cube by 3. N cube by 3. What is the first thing? We have to give a name. Let P of n. For n equal to 1, this is the usual process only, you know, that's why. P of 1, left side will be what? 1 square and right side 1 cube by 3. Of course, 1 greater than 1 by 3 only. 1 is greater than 1 by 3 only. Therefore, what? P of 1 is true. You know this. Everything, I think you just pause the video and write it. Or first you completely have to watch and try to write yourself. Okay, fine. Now what is the next assumption? Assume that P of k is true for some positive integer k. P of k is true for some positive integer k. That will be what? 1 square plus 2 square plus 3 square plus etc. plus k square greater than k cube by 3. Equation number 1. Now we have to prove that P of k plus 1 is also true. To prove P of k plus 1 will be 1 square plus 2 square plus 3 square plus etc. Last will be k plus 1 whole square, but we people used to write what? Previous term also, k square, that is greater than what? K plus 1 whole cube by 3. Don't forget this part is what? This part is what? Smaller part, don't forget about that. This part is what? Smaller part. So smaller part we can subtract anything, bigger part we can add anything. So this is the smaller part. So equation 1 already we wrote. Now the proof. Proof usually in the case of inequality, we are starting from equation 1. So proof. From 1, we have, what we have? 1 square plus 2 square plus 3 square plus etc. plus k square greater than k cube by 3. See, don't forget, we want to get a k plus 1 whole cube. What is k plus 1 whole cube? It should be there in your mind and you have to write that is in working column. What do you want to get? K cube plus 3k square plus 3k plus 1. That is k plus 1 whole cube. If anybody, this only we want to get. K plus 1 whole cube equal to what? K cube plus 3k square plus 3k plus 1 by how much? 3. That only this one, what we want to get. So from 1 we have this one. So I told you, first what you have to get? Left side you want to get k plus 1 whole square. So both sides, initial addition on both sides, initial multiplication on both sides, that already we done in previous 3 questions. So adding both sides, what? K plus 1 whole square. Adding k plus 1 whole square on what? Both sides. What will be? 1 square plus 2 square plus 3 square plus etc. k square plus k plus 1 whole square greater than k cube by 3 plus k plus 1 whole square. So our left side is ready with us. Now right side, just I am going to take LCM. K cube plus 3 into k square plus 2k plus 1 by 3. K plus 1 whole square, you know, k square plus 2k plus 1 and this 3 I transposed. So it will be what? K cube plus 3k square plus 6k plus 3 by 3. So we got like this. Actually we want to get what? K plus 1 whole cube means we need only k cube plus 3k square plus 3k plus 1. So I told you already, smaller side you can subtract anything, bigger side you can. So this is the smaller side, no? So what we have, I'm just writing here, listen. We have right now 1 square plus 2 square plus etc. K square plus k plus 1 whole square. Is it this one? This line nothing is there, only to show the simplification. So k cube plus 3k square plus 6k plus 3 by what? 3. It is a smaller side. From the smaller side you can subtract anything. I already told you. So actually we want to get this one. Is it? This means this only. So k cube is okay. 3k square is also okay. But there is 6k. 6k we don't want. We need only what? 3k. So one 3k I subtracted and one 2 also is subtracted. Because we want to get k cube plus 3k square plus 3k plus 1. So from 3k to get from the 6k we have to remove. So final answer 1 square plus 2 square plus etc plus k square plus k plus 1 whole square greater than, what do you want to get? K cube plus 3k square plus 3k plus 1 by 3. Is it? By 3. So that is what this only you want to get. Because what is this? K plus 1 whole cube. K plus 1 whole cube by 3. The next line you have to write this greater than k plus 1 whole cube by 3. That only we want to get. Thus p of k plus 1 is true whenever p of k is true. I hope you understood this part also. You understood. So for 4 questions I done. You please go through this one everything properly. I hope you understood it. Please go through again and again and check again. Okay, one more question we can write. Prove that 2 raised to n greater than n. 2 raised to n greater than n by using what? PMI. What's the first thing? We have to give a name. Let p of n. So little bit quickly I am moving. Please listen. For n equal to 1, what will be? P of 1, 2 raised to 1 greater than 1. Of course, p of 1 is what? True. Because it is 2 raised to 1 greater than 1 only. Now what assumption? What will be 2 raised to a greater than k? Equation number 1. To prove 2 raised to k plus 1 greater than what? K plus 1. Proof. We have from 1, we have 2 raised to k greater than k. This we have. So to get this one, 2 raised to k plus 1 means both sides we have to multiply 2. So multiply both sides what? 2. So what you will get? You will get 2 raised to k into 2 greater than k into 2. So 2 raised to k plus 1 greater than 2k. Actually we want to get what? 2 raised to k plus 1 is only k plus 1. It is a smaller side. Smaller side you can subtract anything to get the result. We want to get to k plus 1. So to get to k plus 1 I am subtracting this one. Minus what? K minus 1 I am subtracting. Minus k minus 1 I am subtracting. K minus 1 of course it will be a natural number. Because k is a natural number only. So k minus 1 is also a natural number. So k minus 1 I am subtracting both sides. Only smaller side. So what will get? 2 raised to k plus 1 greater than 2k minus k is what? K plus 1. From where I got k minus 1, of course you will have the doubt. Only the thing, how will get to k plus 1? From 2k what we have to? Anyway 1k should go. From 2k, once k should go. Then k will be there and we want to get it. So this I done. So this p of k plus 1 is true whenever p of k is true. So please go through repeatedly. This is the inequality based questions only I discussed it, and remaining questions already we discussed in our previous classes. So please go through this one repeatedly. Any doubt is there, you can ask anytime. Okay, that's all. Bye.